Since we've got the output, the remaining task is to analyze the outputs. Okay, there are two types of the raw outputs from NS. The trace and the animation playback. The trace is a formatted textual record of the proceeding of the whole simulation. Usually, the statistics we expect from a simulation include throughput, delay, load, overhead, etc. But I will show how to get the stats that we expect from the raw output. There are two options here. Option 1, compute the stats we want right in the model C++ source or in the optical script. This option may be not so flexible. In this tutorial, I'll introduce option 2. Analyze the trace to get our stats. To analyze the trace, the tool we'll use is the GNU-awk. It's an implementation of the awk language. Awk language is very suitable for analyzing formatted text data file. Usually a awk script is made up of 3 sections: the begin block, the body, and the end block. In begin block, we'll do some initialization work, and the body will be executed recursively for each line of data file. After the awk script manipulates the raw output, we get a data set that we expect, the stats. Then we may try to plot or visualize the data set. I know 2 options. The first one is XGraph, the second is GNU-plot. GNU-plot is more versatile with more options. Here I will make a demo on them. First is the awk script. Okay, before that, let's have a look at the trace file. Oh, sorry. I have to run it to get a trace file. Here's the trace file. It's a formatted text, a record of the events that happened within the simulation, like enqueue, dequeue, or receive a packet, the time for the event, and source node, desk node, packet type, packet size, etc. Here we'll use the awk file to analyze such a formatted text data. What's the matter? Okay. Here in the begin block, we initialize some variables. We'll get 2 types of data out of the trace. One is the total packets received, the other is the throughput of the traffic. So here we create a variable to store the total number of packets, and here we go to the body of the script, which will be executed recursively of each line of the data. Here we will calculate the stats every 50 milliseconds. We'll calculate the throughput in a fashion shown here. We'll add all the bytes received together and then divide it by the time interval. And then we will redirect the results into a file named dataset. And at the end block, which will be executed when the awk script finishes it runs, he will print the total number of packets received. Okay, to try this awk script. Okay, we'll run it. File name, the awk file name is cbr awk, and then the data file will handle is example1 trace. Okay. After the run of the script, we'll get the total number of packets, 803, and then we've got another file. It's the output dataset. Let's have a look at this file. It's a formatted dataset. The first line is the time spot of each receive, and the second column is the traffic size. Okay, this is the result of the awk script. Then we'll try to plot this file. First we'll try xgraph. Okay, here this is the output of the xgraph. After that, we'll try the more elegant to GNU plot. GNU plot will have its own command line. It's an interactive tool. Here we'll use another script to specify the command set for GNU plot. You can input these commands line by line into the GNU plot command line interface. Here I just type them into a script, and then I'll load the script into the GNU command line, GNU plot command line. Okay. Here I run GNU plot into its console, and then I load the command set, name the plot this. Okay, after that, GNU plot will draw the curve for me. Let's have a closer look at the output. Remember the parameters of the traffic source. Each packet is 500 bytes, and then the interrupt time has an average of 5 milliseconds. So the throughput should be 100 kilobytes per second. Yes, our curve shows that the average may be 100 kilobytes. And since we specified the interrupt time to be random, so there will be bursts of traffic, so the throughput is not constant. Okay, until here we have finished phase 4 of the whole process. Then a short summary. In this tutorial, we summarize the general workflow for NS2 simulation. There are 4 phases. Phase 1, to implement protocol models. For this purpose, we'll have to do protocol modeling and C++ programming. Then phase 2, set up scenario. Here we'll use the optical script to specify the topology and traffic. Then we run a simulation. After that, we got the raw outputs, the trace, and then we'll use awk script to analyze the trace to get the dataset we want. After that, we may plot or visualize the dataset with GNU plot. Okay, I appreciate any comment. Thanks for your time.